We're now going to move on to talk about how to do basic triangle proofs. Basically, it comes down to doing the same thing that we've been doing, but just being explicit with our justifications. So there's a nice little checklist here on your notes that you can use to help you get started if you get stuck. The first thing we always start with in a proof is our givens. You can also work from the bottom up and put what it is you're trying to prove at the bottom if you would like. You can use the givens to mark the triangles with rainbows. That just means my angle marks. Or with tick marks. Okay, so mark anything they've given you. Look at what they gave you. Is that enough markings for a postulate? The postulates are what we've talked about. That just means side, 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 angle, side, etc. So things like side, 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 angle, side, etc. That's what it means by postulates. What did you mark on the triangles that is not given? Write that in a proof. For example, if they give you bisect, then your justification for saying something is congruent could be the definition of bisect. If it says midpoint, then you could use two things are congruent by the definition of midpoint. If it's vertical angles, then vertical angles, this lost the little angle marking right here. Vertical angles is a reason. And if the triangles share a side, then reflexive property is a reason. And here's another, the symbol didn't come through right here. Are there 4 congruent signs or symbols on the left-hand side of the proof? So for these triangle ones, you need to have 4 congruent statements on the left-hand side. So that's going to give you things like 3 sides, and then you'll make a statement about the triangle. So let's look at some of these examples. So the first one says, given that CY and ZR bisect each other, I want to prove that triangle CAR is congruent to triangle YAZ. So the first thing we always start with in a proof is your givens. So my given is CY and ZR bisect each other. And my reason is that's given. And I'm going to write each statement that I know in a different color so we can kind of keep track of that. So the next thing that I'm going to do is mark my triangle based on that information. So based on that information, CY and ZR bisecting means that CA is congruent to YA. And that ZA is congruent to RA. And I can put this in one statement. ZA is congruent to RA. And the reason for that is that's the definition, it's what it means to bisect. Definition of bisecting. Now we want to think, what else could I possibly add to my triangle? Well, I notice I have vertical angles, so I can say that these 2 angles I'm marking right now are congruent. Specifically, the angle CAR is congruent to angle, make sure you match your letters, YAZ, and the reason I can say that is that they are vertical angles. Now let's look at what I have. Both triangles have side angle side, so I can conclude that triangle CAR is congruent to triangle YAZ, and the theorem is side angle side. And I'm done with that proof. So it really comes down to writing what's given and adding any additional information that we need. So looking at the next one, N is the midpoint of AB, and then it's giving me two of these angles are congruent to each other. So I'm going to start with just writing all those givens into my first statement. So N is midpoint of AB, angle Dan is congruent to angle CBN, and angle DNA is congruent to angle CNB. So those are given. For the angles, I'm going to go ahead and mark those. DAN is congruent to CBN, and then DNA is congruent to CNB. So I'm going to add those onto my figure, and now I need to see if I can make any other conclusions. So since they told me that N is the midpoint of AB, that means that these two segments are congruent to each other. So AN is congruent to BN, and the reason I can say that is the definition of the midpoint. Now what I can do is look at the two triangles. What information do I have in both of the two triangles? I have angle, side, angle in both of the triangles, so I can do my final line of my proof. My goal was to say that triangle DAN is congruent to triangle CBN, and I have enough proof of that by angle, side, angle. Look at this one, we have that word bisects again. Given AN bisects angle CNI, and that angle C is congruent to angle I, prove that the two triangles are congruent to each other. So what do we always start with in a proof? We start with our givens. So AN bisects angle CNI, and angle C is congruent to angle I, and those are both my given. Then I'm going to go to marking my figure for C. Angle C is congruent to angle I. All right. Now, I haven't used the fact that it says AN bisects angle CNI yet, so I'm going to add that in my proof. What does it mean for a segment to bisect an angle? Well, it means that it's splitting into two equal parts. So CNI is being bisected by AN, so that means this angle is congruent to that one. So let's write that out. Angle CNA is congruent to angle INA, and that's by definition of bisect. They told me a bisect, so I'm just writing out explicitly what is being bisected. Okay? Now, I'm out of information from my givens, so that's when I want to take a look back at my figure. So in my figure, I'm just going to erase a little bit of this. You will see that the figure has a shared side right here in the middle. So I can say that that shared side, AN, is congruent to AN, and that is the reflexive property. Now let's see if that's enough information if I add that little mark right there. Why, yes it is. They both have angle, angle, side. So I can make a statement about my triangles. So triangle CAN is congruent to triangle IAN by angle, angle, side. Last one, BU bisects LE. Angle B is congruent to angle U, and we want to prove that the two triangles are congruent. So what do we start with when we do a proof? Start with your given. BU bisects LE, and angle B is congruent to angle U. So B is congruent to U. Now let's move on to, and those were given, so we'll add that. So we've marked angle B is congruent to angle U, so let's look at the bisects. BU bisects LE. So that means that the segment LE is being split up into two equal parts. Now, this is different than the first problem where the two segments were bisecting each other. In this one, BU is bisecting LE. It does not necessarily mean, before I've proved it, it doesn't mean that LE is bisecting BU. So we can only mark this one thing as congruent. So let's add that line to our proof. We would say that SL is congruent to SE, and that is the definition of bisect. And last, I noticed that we have a pair of vertical angles in here. So I could say that angle LSB is congruent to angle ESU because they are vertical angles. Now if I look at my two triangles, I have angle, angle, side, angle, angle, side. So I can say that triangle BLS is congruent to triangle UES by angle, angle, side.